Good morning, students. And once again, I welcome you all for the digital classroom of Science and Technology Part 2. Dear students, since last Monday, that is 5th of July, we have started with the live sessions of all the subjects and for all the divisions separately. So, this Monday on 5th of July, we had our first Science and Technology live session in which myself and Poonam teacher we had discussed about the paper pattern. After the completion of this lesson, I am going to discuss the paper pattern in detail in one of the video lecture in which I will be giving you the full paper pattern and I will be explaining you to attempt the questions, how much to write, how to score out of marks for the different questions. So that I and Poonam, we both will be discussing separately in our own science period lecture. Now let's come back to the lesson. Dear students, we had already started with this lesson number 5 towards green energy, and we had already finished with first 3 parts of the lesson. Now in this lesson, we had studied about the energy and the uses of energy. In this lesson, we have studied, or we are rather studying, the various sources which are now used for the generation of electrical energy, the methods which are used for, the scientific principles which are used for the generation of electricity, as well as the advantages and disadvantages of these different methods. And we have also studied the meaning of green energy. Now, the basic principle of generation of electricity is based on the principle of electromagnetic induction, which was invented by Michael Faraday. And according to this principle, whenever a magnetic field is created around a conductor, a potential difference is generated across the conductor. And this principle is used to generate the electrical energy. There are different power plants where the raw material used for the production, for the generation of electrical energy is different, but the principle for each power plant is same. So, let's continue with the lesson. Different steps. The energy source in the different plants are different, whereas the further processes are almost same in all the power plants where the electrical energy is generated. In the very first step, you can see the raw material which is used, that is the proper energy source to run the turbine. So when a liquid or a gas is directed on the blades of the turbine, it starts rotating and the kinetic energy from the source runs the turbine. Now this turbine is connected to the generator, and thus the in electric generator, it starts rotating and electric energy is produced. So this is the generation of electrical energy. Now we will just revise the different methods, the different power plants, how the different power plants they work on the production of electrical energy. The very first one, if you remember, was the thermal electric power station. See, the first one is the flow chart showing generation of electrical energy using thermal energy, and in the second one, the different steps of energy transformation is shown. how the energy is transformed from one form to another. So let's revise. In the thermal electric power station, the raw material or the fuel taken is the coal. We know that coal has the chemical energy. This chemical energy is used in the boiler to convert the water into steam, right? So water is heated in a boiler, and with the help of the thermal energy from the coal, the boiler starts working and the water starts converting into steam. This kinetic energy of the steam starts rotating the turbine, and from here the water is condensed and is again sent back to the boiler to convert it into steam. The turbine in turn starts moving the generator, and thus the electrical energy is produced. So in thermal electric power plants, the chemical energy in the coal is converted into the electrical energy through the transformation of energy. Like first one is chemical energy in coal. Thermal energy, it is converted into thermal energy. Thermal energy is converted into kinetic energy in steam. In turn, this kinetic energy rotates the turbine, and then in turn the electrical energy is generated. The second power plant is based on the nuclear energy. Here we have to take the radioactive elements, uranium or plutonium, and they are converted into a very unstable elements. The unstable element, that is the uranium, which is the isotope, right? For we have to take, in the nuclear reactor, we have to take uranium 235 and it is converted into the isotope uranium 236, and as it is very unstable, it immediately converts into barium and krypton, where the neutrons are released, and these neutrons, they cause the fission of uranium 235 again, and this chain reaction continues, right? So here also the nuclear reactor for nuclear fission, which in turn converts the water into the steam. Steam kinetic energy turns the turbine. Again from the turbine, the steam is condensed and it is sent back to convert into steam. And this turbine in turn starts rotating the generator, which generates the electrical energy. And if we see the energy transformation, it is same except the first form, that is the nuclear energy. In the earlier one, we had taken the chemical energy. So nuclear energy converted into thermal energy, into kinetic energy, in the kinetic energy in turbine, and in turn the last is electrical energy. Third one was power generation plant based on the natural gas. Now here the fuel used is the natural gas, and here the turbine is run by gas which is at very high temperature and pressure, right? And this high temperature and pressure is generated by the compressed natural gas. Okay. Then this combustion chamber, in which the natural gas is there at a very high temperature and pressure, it starts rotating the turbine. Turbine rotates the generator, and in turn electrical energy is generated. The transformation of energy is chemical energy present in the natural gas, the kinetic energy generated due to combustion of natural gas, kinetic energy in turbine rotates the generator, and the electrical energy is generated. Now we had studied till these three power. Now the next power plant we are going to start is hydroelectric energy power plant. Now in this power plant, the potential energy of the water reservoir is used. You might have seen the dams. The water is stored there, and then the potential energy present in this water reservoir or the dam is converted into kinetic energy by allowing the water to fall at a very great speed, and thus the potential energy of water gets converted into the kinetic energy. Now this kinetic energy, which is due to the fast flowing of the water, this falls on the turbine which are placed at the lower levels, because water falls from a higher level. So it falls on the turbine with great speed, and this kinetic energy of the flowing water, it starts turning the turbine, right? And then in turn this turbine, it starts rotating the driving the generator, and thus the electrical energy is generated. So this is the different stages in the hydroelectric power plant. Now how the energy is transformed from one form into another. Now this is a very conventional energy source, right? The potential energy that is present in the water when the water is stored in a reservoir or it is stored in the dam. So this potential energy of water is converted into the kinetic energy of flowing water, right? And then this kinetic energy of flowing water turns the turbine because it's falling from a great height. Now these turbine, they starts turning the generator, driving the generator, and then the electric energy is produced. So this is all about the hydroelectric power plant, right? The first one is the different stages, and in the second one we can see the form of energy transformation from potential energy to kinetic energy. Then the schematic of hydroelectric plant, right? Just observe the picture. So this is the pictorial representation of hydroelectric power plant. The water is collected in the reservoir, right? The gates are there to allow the water to flow with great speed, and then this water, the kinetic energy of the flowing water, turns the turbine. Turbine in turn starts driving the generator, and then the electrical energy is generated. Now students, in your textbook on page number 54, use your brain power questions are given. So we will just try to answer these questions. The first one is with reference to point B. Now this is point B. With reference to point B, potential energy of how much water reservoir in the dam will be converted into kinetic energy. Okay, that means at the point B, the potential energy of how much water reservoir will be converted into kinetic energy. Now, when the gate at point B is opened, right? So the water from the reservoir will start flowing, and the potential energy of this stored water, it will convert into the kinetic energy of the quantity of water that is let out through the gates. Whatever amount of water is allowed to go through the gate, only the kinetic energy of that total water is converted, used to turn the turbine. Okay. Now second question is, what will be the effect on electricity generation if the channel taking water to turbine starts at point A? So here at point A, what will be the effect on electricity generation if the channel taking water to turbine starts at point A? First it was at point B, now it is at point A. So what will be the effect? Just think, students. Yes, is there any difference in the height of A and B? Yes, A is at a greater height than B. So if the water is allowed to fall through the point A, then what will happen? Because the point A is at a higher height compared to B, the water will gain more speed. More speed means more amount of kinetic energy, right? And more amount of kinetic energy means the rotation of the turbine blades will be more, right? So the difference between point B and point A is point B is at a lower level, so the kinetic energy in the water passed through point B is less compared to the kinetic energy of the water which is allowed to flow from point A, because it is at a greater height and thus it will gain more kinetic energy, so the turbine will move with a greater speed, and definitely the amount of electricity generated will be more. Now let's move on to the third question. What will be the effect on electricity generation if the channel taking water to turbine starts at point C? Now we had seen the height of A, we had seen the height of B, and height of C point is much lower than the point B and the point A. So what will happen? The point C is at a lower height. So the kinetic energy generated will be quite less because the flow of water will be less compared to the flow of water from B and A. And definitely it will affect the rotation of the turbine. The speed will be less and thus the electric generation will also be less. So it depends upon the height of the point from where the water is allowed to fall. Okay, so this is all about hydroelectric power plant. Now, as students, you know that every coin has two sides. We had seen in the earlier power plants that there are certain disadvantages because there the different types of fuels are used, like the coal is burnt, natural gas is used, then radioactive elements are used. So the fuel is used in one or the other form, and when the fuels they burn, they create pollution. The biggest advantage of the hydroelectric power generation plant is that here no fuel is burnt, right? We don't burn any fuel, we don't have combustion taking place, and thus there is no pollution at all, right? There is no air pollution in the hydroelectric power generation. Second point is that if we store sufficient amount of water in the dam, we can generate the electricity as and when required. Whatever amount of electricity is to be generated can be generated, and whenever it is required, we can have the generation of electricity. And the third advantage of hydroelectric power generation plant is that here, although the water reservoir is used for power generation, it can be replenished, right, during rainy season, which will lead to the uninterrupted power generation, right? So during the rainy, so it is a replenishable water source. The water which we collect in the dam, that is a replenishable water source. So it can be replenished during the rainy season, and thus we can have electricity generation without any break. Now these are the advantages. Now there are some disadvantages associated with hydroelectric power plant. The first issue is that the water is stored in the dams, right? So this backwater issues are introduced in this, which is like when the dams are to be built, the ground is to be cleared. So the people, villages, forest, their agricultural land, all these are to be displaced. This is the biggest disadvantage of hydroelectric power plant. You might have visited any of the dam, right? It is a quite big construction. So the rehabilitation problems are there. And then suppose the dam is full, then what? So at times, the gates of the dams are open, which lead to the flood-like situation in which the villages they get submerged, the forests they are submerged, and thus it creates loss of life, loss of forest, loss of agricultural land also. And second disadvantage is that the obstruction of the flowing water of river, it has the adverse effect on the living world in the river. The flora and fauna in the river, they are imbalanced. They have adverse effect because of the flow of river is obstructed. So students, these are the advantages of hydroelectric power generation and the problems which arise due to the hydroelectric power plant. Okay. Then this is just for your information. You should know how many hydroelectric power plants are there. Like we had seen the places and the capacity of different power plants. So regarding the hydroelectric power plants in India, in the state of Uttarakhand, at Tehri, there is a hydroelectric power plant which produces 2400 megawatt of electricity. In Maharashtra, it is Koyna Dam, quite famous, and it produces 1960 megawatt of electricity. In Andhra Pradesh also, we have Sri Shailam power plant, which produces 1670 megawatt of electricity. And in Himachal Pradesh also, we have Natpa Zakri hydroelectric power plant, which generates 1500 megawatt of electricity, right? See students, I always tell you that you should always go for comparative study or correlation. Now here we had finished with 4 power plants, and you just compare them. Compare in the sense which fuel is used in the first one, which fuel is used in the natural gas, which fuel is used in the nuclear power plant, what is used in the hydroelectric power plant, right? And then advantages of these power plants and disadvantages of the power plant. So like this, you try to remember, you try to understand. Okay. So I am not going to continue beyond this because the time is almost up. So we have one more power plant, that is the windmill. Okay, the wind, how is it converted into the electrical energy, that we will continue in the next period. So students, with this we finish with the hydroelectric energy, how the hydroelectric power plant works. Now, as the time is up, so next time we are going to start the last power plant in which the wind energy is used to generate the electrical energy. So till then, thank you students. Stay safe, stay home, and please take care of yourself, your family, your friends, your relatives. Bye.